Hello everyone and welcome to the lecture on DynamoDB, LSI and GSI. So LSI is local secondary indexes and GSI is global secondary indexes. So what is an LSI? An LSI or a local secondary index is an index that shares its partition key with the base table but has a different sort key. So basically you have a partition key and which is called as a hash key, and then you have a range key or the sort key. But in the case of an LSI or local secondary index, it will have the partition key same. It must be same as the base table, but you can have a different sort key or the range key. And this means within the same partition or grouping, LSI provide alternate sorting and quick access to data. So you can have basically on the base table you can have a partition key and a sort key, but with this LSI functionality you have to take the same partition key and you can have some other sort key. So you can have alternate sorting pattern within the partition, and you can have quick access to your data. So why use LSIs? So LSIs are essential when the primary key does not cater to all our querying needs, and they allow us to fetch data without resorting to inefficient scans. So otherwise you have to perform the scan to retrieve the data that you need. Another benefit of LSI is the ability to sort data differently within the same partition. And by optimizing our queries, we can also cut down on cost, and scans are expensive and should be avoided when possible. So LSI limitations. First is, it's important to note that LSIs must be defined when you are creating the table, and you cannot add them afterward. So it is only during the creation time that you can create the LSIs, and a single table can have up to 5 LSIs. So during the time of creation, make sure if you want to design your query patterns and all, so you have to do some designing before that. So you can do some testing on development environment, and if you are satisfied, you can probably delete the table and recreate it, but not like once it has gone into production and it's already there's a lot of data. So then you have to do a lot of re-engineering around this. And once an LSI is defined, it is set in stone, so you cannot modify or delete it. And LSI consume provision throughput. So if you have provision throughput mode, LSI will consume the same RCU and WCU, read capacity units and write capacity units. So LSI will consume the same whatever you have defined on the base table. So while they offer the flexibility, they also come at a cost. So for example, to make this concept clear, let's consider an e-commerce platform where we want to track user behavior. We have a user activity table with user ID as the partition key and timestamp as the sort key, which will help us understand when a particular activity occurred. So for this this one is the partition key or the hash key, and this one is the range key or the sort key. So user 1, and then this is sorted in the data, and for user 2 this is sorted, and then user 1 again some data has come in. So for example, this is the on the base table. Now imagine wanting to fetch user activities not by time but by activity type. So for example, we have one more query pattern that we want to fetch user activity based on the activity type. For example, segregating purchases from the page views. The primary key structure won't suffice for this need. So enter LSI. We could create an LSI with user ID as the partition key and activity type as the sort key to efficiently fetch data by activity type. So after that design change, if that goes in for this LSI, it would look something like this. So on the LSI, we are having user ID again as a partition key. So this part cannot change. So partition key in the LSI so you can have 5 LSI for example. So in all those 5 LSI, user ID being the partition key will never change, but you can have alternate column as the sort key or the range key. So in this case, let's say this is LSI 1 and we have activity type being added. So this one goes here. So timestamp on the base table is the sort key, but in this LSI, activity type is the sort key or the range key. So herein it goes. So now on the right side, we with our LSI, the same data is rearranged to highlight the order of activity type, and this is how we can fetch based on the user ID and activity type. And this is providing an alternate way to query the data. Otherwise, we have to do full table scan, which is inefficient. So imagine querying querying with LSI. So imagine querying all purchase activities for a user with our So this I had already talked about. So with our LSI, this becomes straightforward. So query purchase activities for a user. And the key takeaway here is efficiency. Without the LSI, we would have to scan through all activities to filter out purchase ones. So if we want to say activity type of purchase, which has higher importance, the LSI let us fetch this data in a more direct manner. So some LSI best practices: always create LSIs when you are certain about alternate query patterns, and don't just add them speculatively. So because it has to be created at the table creation time, so you should be do very good analysis on the query patterns. And it is crucial to keep an eye on your provision throughput. Ensure LSIs are not wastefully consuming capacity. And remember, LSIs are one of the tools in your DynamoDB toolkit. Sometimes global secondary index or filter expressions might be more suitable. So you can consider GSI or filter expressions, because these can be created afterwards, or filter expressions can also be used. So now we will talk about global secondary indexes in DynamoDB. So a global secondary index allows for queries on non-primary key. So this is important. Now we have some additional flexibility, because we don't have to stick with partition key or the hash key. So in DynamoDB, it's called as partition key, primary key, or hash key. The term that it's being used is hash key, but just think of a primary key in any SQL table. So this provides flexibility beyond the table's primary key structure. So this is something extra, and this becomes crucial in scenarios where we want to access data in ways other than what the primary key would allow, and it is about optimizing access patterns. So one more thing, each table in DynamoDB can have up to 20 global secondary indexes. So this is the default, and local secondary indexes, which we have seen, the max limit is 5, but this one has 20. And anyway, because LSI has to be created at creation time, so 5 is fine, but herein you have more flexibility. So understanding GSI mechanics. So unlike LSIs, GSIs are not tied to main table's partition key. They can have entirely different partition and sort keys. This means you can essentially restructure your data access patterns almost as if viewing the data in a completely new table. So let's see one real world scenario. So let's imagine an online forum. Each post has a unique post ID and a user ID of the author. So our primary table might use, for example, this post ID as a partition key. But what if we want to fetch all posts from a specific user? So here GSI come to the rescue. So in this table, which we have defined, post ID is the partition key or the primary key, but now we want to fetch based on the user ID. So now we will just create a GSI on the right side. This side, our GSI provides a view where entries are sorted by user ID. So this is basically grouped by user ID, which allows efficient access to all posts by particular user. So we have created a GSI where user ID is there. So basically this user ID path will come. So this is sorted by user ID, and in this case it's sorted by post ID. So some benefits of GSI. GSI provides a profound ability to reshape access patterns without restructuring the main table or duplicating the data. But remember, with great power comes great responsibility. GSIs can consume additional capacity and storage, so they should be used judiciously. And some best practices with GSI. GSI provide some best practices are like clear use cases, avoid unnecessary GSI creations because they will cost extra, and so just avoid extra resources and cost. So make sure you design them carefully. And some best practices again on monitoring, monitor GSI performance, GSI usage, and avoid overspending on capacity. So make sure you weigh in the pros and cons between LSIs and GSIs, and based on your specific business requirements or the needs, and understanding their unique strengths. And that's all. Thanks for watching.